saco y... En el plano. Fuera, fuera. Eso es.
Luego vamos a hacer
Sí, un segundo.
Et je ne sais pas où c'est Georges. Il est engueulé quand il est en train de parler. Ah,
¿Lo quieres así? Bien. Un segundo. Ahora tenemos...
I am leading the Strategic Export Control Project, which is one of our institutional activities, dealing in particular with the export control of dual-use goods. So dual-use goods are those goods which have both civil and military applications. So they can be used to develop normal, let's say, illicit activities, but also are instrumental to building nuclear weapons and non-explosive weapons of mass destructions. First of all, we talk about materials, equipment, technologies, software. So it's not only about, so this is to build components, to build, for example, equipment which is needed to process gases and other dangerous stuff. For example, here I'm showing material and equipment which is used normally in our labs here. So it was purchased to do research activities. But of course you can do certain types of research activities or even more expanded to gather more dangerous material which can be used in a weapon. And a weapon could be both a nuclear or a chemical one or even a biological disease spread around. Parts of missiles which can be used to deliver some of these weapons of mass destruction. And sometimes I mean, it's very hard for people to realize that they have in their hands something which is related to weapons of mass destruction. This is a pressure transducer. It's absolutely normal. I'm not going to show the brand, but it's absolutely normal. But it can be used also to measure the vacuum in a process chain which is used to produce dangerous materials. First of all, the export control process is a very, very complicated one. It first of all relies on compliance of suppliers. And suppliers include researchers as well, but of course manufacturing companies and other. First of all, they should know that what they use and produce and try to sell is dual use, so appears on the official list issued, for example, in EU Regulation 428 as Annex 1.
that's a huge list, isn't
It's
it?
a huge list, over 200 pages and nearly 2,000 pieces of text, which means materials, software, technology, equipment, and anything. So first of all, the supplier should be aware that whenever he is asked to sell or send information about something appearing here or being quite close to here, they should contact their authorities and seek an export authorization. So awareness of suppliers is the first, let's say, key barrier of the system. This applies, of course, to EU member states, but also in states where there is an increasing and growing industry. In third countries I'm talking about. Therefore, EU outreach also starts from that, making the local actors aware that there is an export control problem and that they shouldn't transfer or sell goods just whenever they get a request. So one of the first activities in outreach is also that. But the second part is once you have the law, to put it in place by having an authority which is able to process the request, decide whether a certain piece of equipment or material or information technology can be sent to the one requesting it. This is the technical assessment and also the end user assessment, which altogether decides whether the authorization can be issued. Yeah, certainly we do not issue any license. We do not do any control here. What we do is research in support to the policy. The policy implies facilitating the harmonized implementation of controls in EU 28. And one of the aspects is trying to apply the regulation all in the same way in EU 28 countries, including, for example, doing technical assessments which are sort of equally accessible to all member states. And for this, there is a EU dual-use pool of experts which we facilitate and contribute, but it relies also on some national authorities which volunteer experts, so that member states who are in troubles in one technical assessment can still rely on a sort of neutral advice. We help the harmonized implementation, as I would say. So just like we help by developing instrumentation which is used at border to detect radioactive equipment, we also help understanding other things which may be on the same track and need to be identified as dual-use items or not. I would say that first of all we started learning how to help the actors in export control, the national actors, the policy actors, and be ourselves a sort of actor in our, let's say, niche of competence. This to help the policy to carry out our own research in understanding dual-use aspects, in developing capacity building programs to help export control authorities, and all together now synthesizing this type of work to also help outreach to other countries. So knowing the essence of the problem, knowing what is the harmonized implementation issues, what are the issues, and also knowing what are the capacity building problems which are met by the implementer of the projects. We know that because we try to do it ourselves. But for what concerns the Center of Excellence, let's say, domain, we don't do these kind of things. We are helping needs assessment, we are helping preparation of terms of reference, identifying new project proposal needs, and evaluating what is done.
Tengo la bandera Croacia. Tengo también un pelín más abierto.
For interviews, but in that case, I give some tough interviews. So why are you saying it? Wow.
So that's quite
So
an
you
important
started
part
when
of
you were
your...
18 years old.
No,
Amazing.
no, yeah, thank you very much. You're too kind.
Well, how did you come to?
Yeah. If you're good.
What is your?
interested.
Is that engineer? Is that interesting stuff that I know he deals with? But and likewise.
In or radiological inspections in companies, in hospitals, in nuclear power plants in Belgium, the Flemish part mainly. Maybe also out of psychological reasons, these things, or mainly, especially in industry, are put in extremely well. I went several times there in the 90s because we had a collaboration or a work.
And those pits where they buried all the vehicles and so on.
Maybe vegetables which were not
Exactly.
healthy,
refused to leave. Yeah, no. And again.
Yeah, it was quite an experience. Also, especially when you entering the town of extremely very unusual, very really a ghost. The reasons for it happening was, of course, it was an experiment which went out of hand. But, well, what we do in our activities is we collect and we validate environmental radioactivity data which we receive from the competent authorities of the European Union member states. And we do that for routine and for emergency purposes. So routine is in order to see whether there is compliance with the basic safety standards, which is the EU legislation for radiation protection. And on the other hand, to see also what, in case of an accident, what might be the evolution or the consequences of a release to the atmosphere or to the water.
And so, thinking of the emergency side of things, one thinks of something like Chernobyl or Fukushima or something like that. Is that the kind of thing that you might be involved with on that side?
That's exactly what we are involved in. So, since 20 years we develop systems for other policy DGs, mainly for DG Energy in this case, which has the political responsibility for responding to the outside world on issues which are related to this. We develop tools, software tools mainly, and also provide a network and maintain that network with the member states in order to facilitate the exchange of this kind of information.
And have you actually had to do this in a practical sense?
Well, the activities were started about 20 years ago, as I said, so it is the result of the Chernobyl accident. During the Fukushima accident there was no need for that because the levels were appreciably lower. It was though monitored continuously. We had a few incidents in the meantime over the past few years. There was the Fleurus incident and also the Krško incident in Slovenia, where one of the systems was activated and it performed as it was expected.
And more specifically, what kind of things are you monitoring? Radiological, I would assume in general terms, but can you be more specific? And what's it telling you?
Well, for the routine situation, we monitor or we ask to provide us information about all the matrices in the environment. So it goes from air to drinking and surface water, to milk and to mixed diet. So especially because we have to see that, as I said before, there is a compliance with the basic safety standards. Which
again, the total dose.
So that the total dose on an annual basis for the population is not exceeded. For the routine situation, for the emergency situation, the scenario is slightly different. There we focus on the early phase of an accident, which means the time that there is still release from the accident place. It can be a reactor or can be whatever radioactive source. And the main difference for that is there is a need for real-time data exchange. And why? Because if there is a release to the atmosphere, the cloud resulting from this can go into any direction and can travel in very short times over a long distance. So people need to be informed about the progression of this cloud, and this is done typically by systems like Ecury and URDEP.
Disaster, how can you practice and rehearse for this? Is this possible to do?
Well, the rehearsal should be done, of course, when there is during peacetime. So we have regular exercises on an international level, but also internal exercises within the Commission. The internal exercises deal more with the operationality of the systems, the communication network itself, and then there are also simulated accident exercises once a year with either the Commission or also together with the Atomic Energy Agency.
And those are played fairly realistically?
And they are very realistically. They are usually They are very realistically. They are prepared months in advance, so that only the country which is hosting the accident is involved together with the international authorities, and then the member states are informed to keep these dates free, but they don't know about the scenario until the moment that it happens.
And
so emergency preparedness in the classical context is mainly related to nuclear power stations, but of course over the past few years we have another smaller scale dimension which can be terroristic activities. And what is the difference with that is, in fact, is, as I said, the scale. In the first case we are talking about international levels. Here we are really speaking about local events. And of course there's a big overlap. We are just developing our activities in that direction, so we still have a lot to develop in that case, but it is in terms of skills and experience, it is very close to each other.
well, I'm just thinking, you're an EC organisation here, but presumably do you have links with, well, first of all, how do you link with the International Atomic Energy Authority? And secondly, linkages with any similar organisations in, I don't know, America, Japan, that kind of thing?
Yes. Well, we mainly work in a European context. We work for, or we provide services to other departments of the European Commission. But the European Commission on itself also has agreements with the Atomic Energy Agency. Even the more driving force behind this are the member states in case of a nuclear emergency. Member states have obligations both to the European Commission and to the Atomic Energy Agency. And of course it's our task to keep the efforts for member states to fulfill these obligations to reduce, let's say, the effort that they have to do to the maximum. So therefore we have a very intense collaboration with the Atomic Energy Agency in order to keep data formats compliant, but also to keep procedures as much as possible, let's say, in equilibrium with each other.
And finally, I suppose, happen.
Of course, yes. We hope that, well, we are developing things we hope we will never have to use.
We'll pause there. Did I give you the opportunity of saying what you wanted? Is there anything else you wanted to add? Or is there anything that we covered that you weren't happy with? For me, it was fine, but you tell me.
Well, I think it was okay for me. It's
okay, thank you for that. It may be that they want to take a closer shot or something. I'll just check, so don't move from. And I understand there's different types of work you're doing, particularly on nuclear security. Tell me more.
So we work in nuclear security mainly on developments of tools for trade analysis, for information monitoring, and that's basically the area of work.
Okay. So how is this information used then for the trade analysis?
For the trade analysis, this information is used by for instance, by the International Atomic Energy Agency, by cross-checking official information that they get from member states. So they have declarations from the member states, and what we do is to use trade analysis to validate what the states reports to them in terms of exports and to a certain extent also for import, but there are also other uses of this type of information. We have developed a specific tool for nuclear security that we call Nuclear Security Media Monitor, which targets specific open source information and nuclear specific ones.
So you say it's an open source, so you're looking at all across the internet, all across the web? Explain to me.
Yeah, there are a number of about 2,500 information sources of general news, this type of thing, and nuclear specific ones, which are about 150. And we have developed with the colleagues working on these activities, we have developed keywords which allows to filter somehow the information and to have it structured in a way which is suitable for the analysis.
And you mentioned these keywords, so is there a focus then on nuclear security, that kind of thing?
Yes, we are focused on nuclear security, but you cannot be too narrow because you have to tolerate some degrees of noise, otherwise you risk to lose too much information. You have to understand that the amount of information is filtered by the system is quite high. There are about 200,000 articles per day, from which with the automatic system we come up to few hundreds. And from these few hundreds we have some colleagues working manually with the support of tools, screening the information and providing, for instance, a newsletter that is for internal use as an alert, but also for distribution within the Commission services, GRC, but not only. It goes to several DGs, including DEVCO. There are two specific activities that we have planned to do for DEVCO. One is the development of a world trade atlas of dual-use commodities. This will be to issue trade profiles for countries which will be useful to focus to identify countries for target to outreach activities. And another thing that we are thinking a project to be launched is an open source center for the CBRN. This is a web-based system which will be used initially to store open source information related with the missions. This is not proprietary information. There are other systems where the information provided by the countries are stored in a secure place, but it's our duty to have this system integrated with the other and useful, and this can evolve in the future to be also useful for specific studies and country profiles. So under the label nuclear security, actually we tackle different issues. So we tackle non-proliferation, which is a broader topic covering threats posed by countries, because normally are countries which potentially proliferate, and nuclear security stricto sensu, which addresses threats posed by subnational actors. So in terms of non-proliferation, our work is mainly to support the International Atomic Energy Agency, also the Euratom Inspectorate, which is responsible for inspections at European plants. In terms of security, there are colleagues working on two detectors for detection of radioactive sources and this type of thing. In overall, the unit of where we work cover different aspects.
When the vehicle triggers an alarm, the operator on the control room has the possibility to analyze better what's happening by looking at the profile of the radiation and coupled with the images of the transit. For instance, you can see here where exactly can be easily seen where we expect the source to be. Here you see the maximum of the radiation profile that corresponds roughly to the back of the van. So already we have a preliminary information that helps us to locate correctly the potential radioactive source inside the vehicle. This laboratory is intended to perform a dynamic test on detection equipment. The purpose is to verify whether the commercial detection instruments comply with the requirement of international standards. So basically, we run through this conveyor several types of radioactive sources or nuclear material and verify whether the instrument respond as expected by the standard. Of course, we can also use the installation to study and analyze the performances also of innovative and prototypic detection equipment that is coming to the market.
Okay, thank you. ¿Para qué sirve esto?
Questo è un strumento, un portal monitors, che serve alla detezione. Questo strumento è un portal monitor che serve alla detezione di materiale radioattivo che può essere trafugato alle dogane.
¿Y cómo se controlla? Che detecta este aparato?
Questo nello specifico è uno strumento che detetta sia sorgenti gamma che neutroniche, quindi può trovare in un trasporto dell'uranio, del plutonio e materiali per la costruzione di bombe sporche.
Ujú. Y está especialmente diseñado para controlar los materiales que van en tránsito de un sitio para otro, ¿no?
Esattamente. Questo tipo particolare di portale è stato progettato per il controllo di traffico di automezzi, quindi auto e camion. E ci sono anche strumenti simili che sono progettati per i pedoni, per le persone. Questo nello specifico è per le macchine.
Bueno, vamos a hacer los planos estos, ¿vale? Y te dejo aquí, hacéis la entrada.
Sì.
Aquí te entrará esto. ¿No? Bien, pues ahí lo dejo. Ok, pues dais una vuelta, él te hace unos planos. Haces unos
Sì,
planos
come,
mientras se conduce.
come la procedura normale. Vamos piano e...
Pero dais una vuelta.
Sì, però la procedura normale, se ti spiego... ¿Puedo ir? Ok. Vale.
Perfecto.
Per il coche.
¿Vas a salir o...?
Normalmente la procedura prevede che sta agli a suelta.
Y ahora te paras ahí.
Sì.
Perfetto.
Che c'è?
Fatto portare una lama. Può
Perché già?
fermare...
Sì, ci sono scelte. Se vuoi dei documenti di viaggio, hai già trovato. È là. Piano, piano. Piano. Dusma, dusma. Apro? No.
Move to scores to press or M
No, exit and...
and il resto. nuclide found.
Okay.
It's saying it's a cobalt 60 source. It's not bananas. It's not technetium, which is used in radiotherapy, for instance, treatment. It's a cobalt source that is used for nuclear security, for detection, R&D, etc. But it's also used in hospitals for treatment. These can be small sources. They can be huge sources that when they are left unattended or thrown as scrap metal, they can be very damaging, as many cases happened in the past. So here it's only one nuclide found. It's a cobalt 60 source. But you can imagine that if it's a mixture of, it will find maybe cobalt, plutonium, uranium, etc.
¿Tú quieres hacer otros planos, ahora otro más tarde?
Identification, isotope identification device. Whereas the ones they took here is just a small detector. This one is allowed, can tell you exactly what there is in it, what source it is, by identifying the source. Not only saying there is a source, but what source. So then you can let the person pass because it's technetium, for instance, for radiotherapy, for instance, or if it detects neutrons, some of these detectors will detect neutrons, then it's an alarm, it's a real one, you have to investigate. If it's gamma, sometimes it's potassium, bananas, sometimes it's fertilizers, etc. So you first detect with a small detector or a big one, and then you identify and you characterize and identify with handheld equipment or spectrometry, bigger spectrometry detectors that cost much more, in fact.
Okay. Vamos a repetirlo, pero ahora sin hablar.
Allarme?
Ha fatto scattare un allarme, sta trasportando qualcosa di radioattivo?
No, un trasporto normale.
Può fermarsi qui che dobbiamo effettuare un controllo più approfondito,
Ok,
per favore.
grazie. Poi dopo.
No, I'm sorry. Yeah, pressed the wrong button. No, but you had first to look for, and then and then you have to,
Yeah, then it's, yeah, you have the key. Este es el control que se haría en una aduana, ¿no?
Sì, questo è il controllo che viene fatto normalmente in una dogana quando un veicolo passa attraverso un portale di radiazioni e fa scattare un allarme. Ci dice che c'è qualcosa di radioattivo all'interno del veicolo e dobbiamo investigare per capire se si tratta di una radioattività dovuta a normale materiale radioattivo, come possono essere le ceramiche, i fertilizzanti che contengono per sé della radioattività, o se c'è qualcosa di illecito. A questo punto dobbiamo andare con un secondo strumento che ci permette di indagare meglio dove si trova e in particolare di identificare il tipo di radionuclide che ha emesso la radiazione. In questo caso abbiamo identificato un cobalto 60 che è una sorgente radioattiva tipicamente usata o nell'industria o nella medicina per scopi diagnostici e che quindi non dovrebbe normalmente essere trasportata se non accompagnata dalle dovute documentazioni per trasporti legali, mentre invece se trasportata illegalmente costituisce un pericolo per la salute e per la popolazione.
Ok, vamos de dentro. Olivier, tú tienes ya aquí suficientes.
Vale, ¿no querías que él hablase de la cosa que estaba contando ahí en la puerta?
Lo que hemos hecho cuando estaba dentro.
Otro film oggi.
Vittorio, estamos preparados ya para hacer lo
Ok.
mismo.
Sì, io ho detto che poi magari sarebbe anche bello gli allarmi, l'arancione e il rosso che non hanno preso da fuori. Quando quieres, ¿puedo?
Sí, estamos preparados.
Ok. ¿El punto de ahí va bien? ¿Puedo salir de allí o prefieres
Sí, sí.
que salgo más lejos?
Puedes salir un poquito más atrás, pero ahí se ve el coche. Un
Ok.
poco.
The operator in the control room has the possibility to analyze better what happens after the triggering an alarm, looking, for instance, to the profile of the radiation coupled with the image of transit of a car. For instance, we can see here that sorry.
Vamos a que se pare él y ahora lo repetimos.
Lo faccio ripartire.
Nos cuenta otra vez lo de antes, ¿no?
Pero que no pasa el coche.
When the vehicle triggers an alarm, the operator on the control room has the possibility to analyze better what's happening by looking at the profile of the radiation and coupled with the images of the transit. For instance, you can see here where exactly can be easily seen where we expect the source to be. Here you see the maximum of the radiation profile that corresponds roughly to the back of the van. So already we have a preliminary information that helps us to locate correctly the potential radioactive source inside the vehicle.
Okay. Vamos a ver esto.
Un po' di sfoccamento.
¿No puedes decir?
No sé. ¿Quieres algún otro elemento con la otra pantalla más grande? ¿Un trípode ya? ¿O te...
La pantalla más grande, ¿quieres decir? Con un poco el aquí atrás, con la máquina.
Sí. ¿Te puedes sentar? Quizás más desde atrás, porque hemos tirado de aquí, igual quizás más de...
En general, segurito con todas las ventanas.
Vale.
¿Necesita luces? No.
Hemos grabado todos los luces.
Hemos
Ah,
grabado todos los
perfecto.
sonidos. Bájate algún plano de corte de su cara mirando. Bueno, no lo hacemos, no te lo
Primero general y después. Sí. Carga de seguridad. Genial.
¿De qué trata esta máquina?
This laboratory is intended to perform a dynamic test on detection equipment.
Ponte il casco, no? Perché mucho muchísimo.
Vale, estamos rodando.
This lab.
Mírame, a mí.
This laboratory is intended to perform a dynamic test on detection equipment. The laboratory allows us to pass through the equipment installed around this conveyor with different radioactive sources of different intensity and different speed, and let's say repeat many times detection condition as far as we want in order to verify whether the equipment performs as expected. In particular, we test commercial equipment to verify whether they comply with the requirement of the international standards. Of course, we also have the possibility to test here innovative and, let's say, evolutionary and new type of detection equipment that can come into the market.
Sembra mucho la mirada eso, ¿no?
¿Puedes decir algo para el nivel de voz?
Sí, para controllare il livello di voce.
Va bene? Volume più forte, più piano? Bueno?
Bueno. Ok. Bueno, ¿de qué se trata esta máquina?
This laboratory is intended to perform a dynamic test on detection equipment. The purpose is to verify whether the commercial detection instruments comply with the requirement of international standards. So basically, we run through this conveyor several types of radioactive sources or nuclear material, and verify whether the instrument respond as expected by the standard. Of course, we can also use the installation to study and analyze the performances also of innovative and prototypic detection equipment that is coming to the market.
Okay, thank you. Va bene?
Yep.
Va bene.
¿Tienes? Todo partido.
L'altro esame è stato lasciato niente. Questo è la carta con...
What's the problem?
This one has corrupted. Si è scritto corrotto fare la configurazione.
Que lo llevan de...
Sí, yo puedo ponerlo, pero yo quería...
No, no lo cambien, no estamos aquí.
Ya la cámara.
Detectors, big detectors. Is it placed to the book or is this intention official?
Sure, yeah.
Anche questo.
Could you lift it again? Yes.
es fácil, ¿eh?
Nada.
Para nada. Pero lo haces muy bien.
Okay. I start.
1 second, let me do the light.
Me pongo
You guys,
In this laboratory, we test usually devices that are commonly used by frontline officers in nuclear security. We tested here personal radiation detectors, spectroscopic radiation detectors, radioisotope identifiers, gamma search devices, and neutron search devices. The instruments are put on these tables, and with this device, that is the reference device, we measure the dose rate. We put this device at a certain distance, and we put all the instruments under test at the same distance. This is a gamma irradiator. When the gamma source is inside, it's shielded by lead, and when it's outside, it irradiates the instruments under test. The neutron tests are performed in the other irradiator, that is this one. And in this case, the shielding is different. It's not lead, but it's polyethylene and cadmium. Here you can see a phantom. That is a phantom used in order to simulate the human body. And with this, we used this phantom in order to test the backpacks that are instruments that are bring by people. So we used this phantom.
So this is the sample cavity of the pulsed neutron interrogation test assembly, or PUNITA as we call it for short. We use this instrument for investigation of methods and instrumentation that can be applied for nuclear security and nuclear safeguards applications. The setup we have right now in the cavity is for a nuclear security experiment. We have liquid scintillation detectors surrounding a fissile material sample, and in the corner you see the pulse neutron generator. The neutron generator will emit a short burst of 14 MeV neutrons, and these neutrons will interact with the sample and produce radiation that we detect in the detectors surrounding the sample. The walls around the sample cavity is made of graphite. There's about 1.4 tons of graphite in this instrument, and we use that to slow down the source neutrons to thermal energy and then interrogate the sample by thermal neutrons. In this way we can interrogate both by 14 MeV neutrons and by thermal neutrons separated in time. And this gives us more information from the sample, and we use that to achieve a lower detection limit for fissile materials. So this is the sample cavity of the pulsed neutron interrogation test assembly, or PUNITA as we call it for short. We use this instrument for investigating methods and instrumentation that can be used for nuclear safeguards and nuclear security applications. The setup we have right now is for a nuclear security experiment. It is about detection of special nuclear materials such as uranium and plutonium. The cylinders you see in the corner is the pulse neutron generator. That will emit 100 million neutrons per second in short bursts and pulsed at 100 Hertz. The detectors you see around are liquid scintillation detectors, and they will record the response from the sample following the neutron interrogation. Okay.
What is this?
This instrument is the JRC drum monitor. The purpose of this instrument is to determine the mass of fissile material inside waste drums. In this particular case, we have our simulated waste drum. It is 500 kilograms of concrete, and we can position our fissile material sources at different locations inside the drum to simulate a real nuclear waste. The instrument is based on neutron detection It is what we call a passive neutron counter, and it will detect the spontaneous fission neutrons from fissile material. And based on the pulse train of neutron detections, we are able to determine the mass of fissile material in the drum. I think we should do it again. I still make a mess out of it. Or I don't know why. Normally I can explain this instrument. What happened there, Samson? Can you push this? Okay. Okay. Okay, I shouldn't do that. Okay, I take it out now. I should have taken a shorter measurement time. And close the doors, huh? So
follow the procedure?
Yeah, there's a procedure. There's a it's a TLC dosimeter, and this is a rate meter. So both neutron and gammas and neutron. Oh, they have it open. Okay, Ronda. You're gone. Who goes to? What's it?
Is far?
No.
Do you know when we have when it's possible?
There's also now. I phone.
Well, this is a piece of steel, and knowing that, for example, martensitic steel is controlled. Right, yes, this is an example of things that appear on this very long list. You may find several...
Put it back, okay?
Right.
So like that, and then
This
hold
is-
it to me, looking at that's right, that's fine, that's great. Now put it
Vacuum pump, and this is an example vacuum pump, because...
the whole thing up, show it to me. That's it. No, well, not too far. That's it. Not too. That's it. That's great. Like that. If you could pick it up and hold it in position, and just hold it there, conspicuous. What is it?
Well, this is a pressure transducer. Once you make the vacuum, use it. So these items and many others appear in the official EU dual-use control list, but it will be updated roughly every year.
Is that part of your responsibility through it for? I think just as a security.
It is divided in 10 categories.
It's tiny print too. I mean, there's a lot of word.
Bájale porque ahí te vas a pegar.
plano de la bandera italiana y en...
fijo, abierto de todo.
Sí, sí, está bien.
Hacer zoom, tilt, lo que quieres, ¿eh?
Da otra vuelta.
Y ahí lo tengo, ahí lo tengo.
Allí tienes el pato. Digo, el pato, el cisne.
Joder, ¿alguien? ¿El cisne?
El cisne está tomando.
Más vale un pájaro volando muy feo.
Está diferente, ¿no?
Sí. No, el fondo, que está más bonito con el agua. Pero está...
Vamos para allá,
Vamos
igual lo
para allá
echamos
si
ahí.
quieres y le doy un euro.
Y ahora que se gira hacia la luz. Eso es bonito. Muy elegante.
Cuidado.
Gírate si quieres.
No, está bien. Lo voy a atrapar ahí.
voy a hacer un poco más rápido porque es... El último fuego.
Lasciati quella da fotografare in laveno.
Venga, abuela.
De barco, se lo quede de... Esto está bien, ¿no? También, ¿no? Aunque lo hemos tenido entrando, pero... La parte como de atrás, ¿no?
Sí.
Ese aquí está bien. Está muy bonito con el... la carretera. Y después sacaré una tele.
Bueno, tengo ganas ya de...
Tele de todo, solo tienes negro ahí atrás. Está más bonito con la nieve y todo eso.
Estoy pensando que igual cuando subamos arriba, porque hay un momento que la carretera empieza a subir. Este es el lago mayor.
From the top, we speak about natural uranium mining and milling. I mentioned already that in Africa we have lots of uranium mines and which we monitor for good reasons. Then you will have a number of steps like uranium conversion, uranium enrichment. This is nothing else than to prepare the nuclear material in the right shape to use it in a nuclear reactor for power production. So you have the fuel production, then you have the reactor there, which is depicted here as graphite or heavy water reactor, doesn't matter. What comes out of the reactor, you have different possibilities. You can either store it, do nothing with it anymore basically, so store it for eternity, or reprocess it to separate the uranium and the plutonium. And the waste will then nevertheless be stored again. The uranium and plutonium can feed back into the fuel cycle. Then the safeguards and security aspect will be, first of all, to focus on the facilities. So you will go to the reactor, you will go to the reprocessing facility, and you will inspect them, all right? To verify that the nuclear materials are properly stored, are properly protected, so the word physical protection come into play there, so that terrorists or other people with malicious intentions cannot easily get access to the materials. There is also the radiation protection aspect, which in the security area we look less at the safety aspects as such of the workers or of the safety of the reactor. That is dealt with under the nuclear safety concept. So if we focus on nuclear security, the keywords here will be physical protection on one hand, so prevention of theft, to be simple, just like you have security around the gold mine or around any non-nuclear thing which is very valuable, or your house. So you basically want to make sure that there are different barriers between a person which would like to steal the material and the material itself, okay? And then you have the accounting of the material. You want to make sure that you know at exactly how much material there is at each point in time.
And what goes in, what comes out.
What goes in and what goes out, so that the operator which uses the material cannot divert material for malicious purposes. And this has to do with nuclear safeguards, with nuclear material accountancy and control, as we call it in our specialty jargon. That means in that particular country that material is transported from left to right, and then you're going to look at the country level, at the state level, towards the consistency of its declared activities with its present facilities. And this is the mandate, for instance, of the IAEA, which is doing, in jargon again, what they call state evaluation analysis. And they want to make sure that they have reasonable confidence that the declarations of the state with respect to all its nuclear activities is complete and correct, whereby the completeness obviously is a big challenge. And that's why you see on the top there that we look, for instance, with satellite imagery towards what's going on in the country. If you find that there are particular indicators for nuclear activities which have not been declared by the state, you might very well want to ask a question to the state to explain. This is what happens today, for instance, in Iran, where the IAEA in the last 3-4 years has been asking to be able to visit a particular site called Parchin, where they have suspicion that there might have been activities which should have been declared to the IAEA and which they have not received declarations for. So the satellite imagery allowed them to observe remotely something going on, and they asked now the state, in this particular case Iran, to give further explanations on these activities. So then to finalize this overall picture, we also look at the technologies which are imported and exported by the country, especially imported, because if they, for instance, in this particular country that I've depicted there with the reactor and the reprocessing, suppose they would be importing centrifuges, then you would scratch your head and you would say, why the hell do they need centrifuges? Because they don't have uranium enrichment facility, at least not declared. And then you will ask questions. The same as when you would intercept at the border, depicted by this small car there, a nuclear material which is traveling outside of the country without declarations. Then you would say there's something wrong with your physical protection, there's something wrong with your facilities, unless you are producing materials in a clandestine way that we are not aware about. So all these are different indicators, and the message here is, that's why you have the small man with the loop on the top. It is a kind of investigative work where you will not from any single technique get a final answer very often. But you will need, it's like a puzzle, where you need many different pieces, which if they are all, let's say, indicators which are in the green area, which are confident with or consistent with the declaration of the state, your puzzle will give you a reliable state picture. If you find orange or red pieces, or you find pieces missing, then you start to wonder what's going on. And that's where our work focuses on.
If I may say.
All right, so if you have understood this part of the work, then you will understand why we subdivide our activities in these 4 blocks. The first is the safeguards, which is what we do to verify that the materials which are declared are effectively present. The second block looks to the verification of undeclared activities, and here you see a man taking swipe samples of a pipe which might be suspicious of having processed nuclear materials. The third block is what we call in our jargon non-proliferation, and there we typically look at a state level, so not at individual facilities, but at the state, as I explained before, and that's where export control, trade analysis, a keyword for tomorrow, where we look at these trade databases, where that comes into play. And finally, if something is intercepted at the border, because it is trafficking illicitly through the region, through the country, then of course we also analyze it in detail, because one thing which we will not go into too much detail, but which is a fantastic scientific discipline, is called nuclear forensics. if you intercept a nuclear material somewhere, can be at the border of a facility, can be at the airport and so on, it's a fingerprint which allows you very often to tell when the material has been produced, what was its intended use, so what was the purpose to produce the materials. Very often, based on impurities, you might also discover where it has been produced or where the material originally came from. That's the interest, for instance, that we have today in the uranium mining activities, because in the mining you will always have certain impurities which follow the material throughout the entire process, even if it's one day used in a reactor, and you would be able to take a sample of the material after it comes out of the reactor, you might be able to still understand where it originally came from. So that's an extremely powerful technique. Now, the facilities that you will visit in the next 1.5 days are a little bit depicted on this slide here. On the left upper hand, you have a facility which is called the active neutron interrogation facility. Because I spoke a lot about nuclear materials detection so far, which is basically holding a detection to if this is a nuclear material, you will take your detector, and if your detector starts to beep, you might understand that this is nuclear material. Now, if I put a cover over this nuclear material, if it would be an alpha emitting material, and I do like this, you will not be able to measure it anymore because alpha particles don't penetrate paper. The beta particles and the gamma particles will still come through. If I take a foil of lead, or I take some moderating material, as we call it, polyethylene or even just water, I will be able to shield this nuclear material so that neither the gamma signal, because the lead would stop it, nor the neutrons, because the moderator would stop it, come out. And then I can't detect it anymore, right? Then I have my detector, it seems to indicate there's nothing to be measured. That's why we've developed now techniques where we will start irradiating with an outside source, with an external source. We will irradiate this material, and it will give much higher energy signals which will penetrate possibly the shielding. And then we can detect in a more efficient way clandestine materials. So this active neutron interrogation test facility is really designed to try and... Because what you do is you will irradiate the material in order to create some reactions in that material, typically some fissions or some neutron scattering and so on, and you will measure the signal from that reaction. Now, this has been tested in the harbor, even in European harbors, on big containers. Now, you have to be sure before you do this that you don't have humans sitting in the container, for instance, which are being smuggled, and you might laugh, but that happens. Okay? So it's not something you can use as a primary inspection technique. You will first radiograph, you will first X-ray the container to make sure that you don't have human beings in there, and then you can subject the container to that type of external radiation and measure the signal. So what happens is they have, I don't have a picture here, but you have to imagine a container truck lane where on the top and on the both sides there is all types of sophisticated detectors, and you will then have one source which will irradiate the container, and all these detectors around the container will pick up certain signals. And from the combination of these signals you will be able to say this container only contains innocent materials or this container has nuclear material inside, even if it's very well shielded. Okay? What we have here in Ispra. One thing I like to point out is at the bottom left corner you see a simple car there, but on top of the car is mounted a laser-based measurement device, which is an in-house developed technology which allows you to verify on a centimeter scale that the buildings of a site which you are inspecting has not been modified compared to, for instance, the situation 1 year ago when you were inspecting the same site. Because I explained that nuclear inspectors are going physically to certain sites, to fuel cycle facilities, but they are not there permanently. They go once per year or once every month or once per week, depending upon the sensitivity of the site. So one of the challenges for an inspector is to very rapidly and efficiently understand what has changed since the last time he or she came there. And this particular technology will allow you to identify geometrical changes, so building changes, a pipe which has been added or a door which has been created which was not there, and just driving around on the site after a few, let's say 15 to 20 minutes for a site like Ispra which has 100 buildings, you might be able to have, based on your computer model which runs behind, an indication of which changes have taken place.
That quickly?
It's extremely quick. It can be done, as I said, for one single building it will take you a few minutes. That's correct. The difference here is that you don't just record images, you basically compare the images to the one that you have stored in your database. And the trick and the technology behind is that you have to be able to map these two in a very precise manner and automatically suggest to the inspector what has changed, okay? That nuclear material is typically stored into big metal vessels, okay? So you can either with the detector, as I demonstrated before, you can try to measure what's inside the container, but you also want to make sure the containers have not been interchanged. And therefore we are developing technologies, which are again in routine use right now, to fingerprint containers. If you take a micrometer precision surface mapping of the container, you can basically identify uniquely a container from any of the others.
Because each one will be very, very slightly.
It has minute different changes, and we even tried to ask the producer of these containers to exactly produce the same type of container, and even if they are new, they don't have at all the same fingerprint. Okay? For the nuclear transport containers, there's no two identical transport containers if you can analyze them precisely enough. And that requires, as I said, this micrometer measurement skills, which have, of course, to be also relatively rapid and efficient, because the inspectors don't have that much time to do this job. But a key requirement for all the detection techniques we use in nuclear security is not to interrupt the normal operational flow. Because we can check whatever we want as long as we don't create extra economic costs or extra delays for the shippers and for the transporters. In the laboratory, one thing I like to point out is that we spend large amount of our time to train and educate people, because being a research center, developing all these types of fancy technologies, they are worthless unless they are being used in the field. You asked already several times, are these things being used? And yes, they are, but that means that the people who use them, they have to be trained. And because there are only few locations in Europe where people develop this kind of technology, they come to us very often for a large amount of training. We might have something like 20 weeks of training courses per year here, where we have groups between 6 or 7 people if it is a very detailed course, also 15 to 20 people if it is courses under the Center of Excellence, which are mainly focusing on trying to train people how to deal with radiation detection at the border, at the airport or at the seaport and so on. Where we have many outside colleagues, we had Southeast Asian ones, we had the Saudi Arabian here, we had the Jordan here, we had Central Asian from Moldova, Kyrgyzstan, Kazakhstan, name them, African and so on. They come and they get trained here on technology which has been installed on their borders. Now, obviously we cannot train every single user, so our focus here is on what we call train the trainers. That means we take people which are part of the Customs Academy, for instance, or the Police Academy, whatever, and we give them the basic skills to understand the operation of the equipment, and we give them the training material that they can take back home to train their people. And it has also to do with the culture of working, with the language, obviously, with the fact that if you have them training together, they will also automatically start to collaborate between them. They will get to know each other, and that's a very important feature of nuclear security and overall protection mechanism. Exactly. And that has a lot to do also with sustainability issues, because if you can work together with already an existing training center which has its own source of funding, which is complemented with additional funding possibly from the EU, there is much higher chance that one day when the funding would stop, that the center continues to operate. And that's really what we aim at the moment, is to build sustainable capabilities. In the inside of the car, what you also notice during training, that people tend to be afraid of radiological nuclear material. So the psychological value of being trained on real, genuine nuclear material, being able to find it in the car, being able to touch it with your hands, and in the evening realizing you're not becoming ill, you will not have health consequences, that's a very important issue.
Make love.
Exactly. No, but we might joke about that, but that's really fundamental, because if people look for smuggling of cigarettes or stolen cars or even human trafficking, you find something that you can speak about, that you know what it is and so on, you're familiar with it. If you find a nuclear material, it's just a black piece of metal possibly, it doesn't mean anything. But then you might believe that you can die from this material, so the last thing you want to do is to go and search for it. You might say, go away, and that's what happened in the past, to be honest. We had many European countries also, where we started this activity 10 years ago, which had the practice, if they detect something at the border, they just send it back. Of course, because you don't want to have it. First of all, you're afraid, but then if you have it, what do you have to do with it? Because it's clandestine, it's illegal. Okay, so what is very important is that we deliver a support to the countries, and that's why I meant the response before. If you detect something, You have to help the countries to be able to store it properly, to handle it safely, and even to cover the costs possibly. Because if you then have this piece of nuclear material there, you have to store it and you have to protect the population from it, so it costs money, right? During my presentation also, if you deal with radiological nuclear security, and the same is true with biological and chemical, you cannot go to one single specialist and hope that he or she will solve the problem. If you look at a terrorist event in a country, and we do this very often when we first go to a country to make them realize the multidisciplinarity of the issue. If tomorrow, and I can give that example also in Europe, if in Brussels tomorrow there is a dirty bomb, there is an explosion with some radioactive material, you will have legal people which will start arguing about who is responsible, who is going to pay, who is liable, what kind of legislation do we have to intervene. You will have the firefighters, you will have the military, you will have the police, you will have the people from the Nuclear Research Center, you will have people from the independent authorities, and they will all have something to do and to say.
You will have friends of the earth.
You will have, and you will have the population in the end also, which wants to be informed. And the last thing you want to happen is that you have 4 different people saying different things about the same event. So what we really focus on is to try and bring all these different stakeholders around the table, make them realize that they all have a certain role to play, but that this has to be organized properly, this has to be trained also between them, because it's not spontaneous. They have to know each other, they have to know exactly what their duty is. Ideally, the journalists have been given upfront some basic education and training on radiological nuclear issues so that they understand when something happens, what is the type of information they will get. And I know our Dutch colleagues have done this. They have prepared leaflets and they even prepared some basic training for journalists so that in case one day something happens, we don't start from scratch in the information provision. You don't know what you don't know. So in order to give them a basic awareness of how you can deal with nuclear materials, the first training courses or the first awareness raising we do is just to expose the problem. And then it's up to the country, to their authorities, to their different organizations to reflect how much is it relevant to them, how much in detail do they want to build up their own protection mechanisms, or how much do they want to rely upon their neighboring country, which might have already some expertise on that particular topic. So in the first role for executing projects, it's mainly focusing on radiological nuclear. The second role is possibly in the meantime becoming more important, is to support DG DEFCO to help the countries in identifying their needs. Because it all starts from what the countries say they need. We are not going there to say, now you have to do this, now you have to do that, and because we tell you what to do. No. That was the past way of working that has been scrapped completely. Now we go to a country and we sit together around the table with a questionnaire in order to do it in a structured format, where we evaluate together with the country what their needs are. And that's a role where the GRC is providing the technical expertise in the radiological nuclear and the chemical biological area. Ideal also completely different backgrounds, so legal people, technical people, force, military or police and so on, and have them discuss how they think they should react when something happens. And that's most of the time the most interesting event that you can, the most interesting question you can ask them. You just play a scenario and you tell them, each of them, what their role is going to be, how they're going to interact. And then you immediately see there is a need for coordination, there's need for discussion, there's need for additional training and so on. Formulation. And then we have this third role is to help the countries to set up projects. You know that today there are almost 40 projects, I think 34 officially running and 6 more in the pipeline under the Center of Excellence. And they have been started from the beginning. And that was very important, to start immediately with some project implementation and not only with discussions about future structures, about needs, about potential ideas. No. To deliver on the ground, in the field, to start building trust, to start knowing the people, and to give also a flavor for the type of support which can be delivered. So currently in the 2014 now we have a mixture of activities ongoing. We have, since the beginning of 2013, we have 34 projects running, okay, and countries are submitting new project proposals. We have ongoing needs assessment. We have evaluation exercises ongoing where we look at the first results of projects. Also, because I mentioned we have been working on illicit trafficking on export control since 5-6 years or even longer. And we are currently, in fact, in my unit here, doing a detailed evaluation of the export control projects which have taken place in the last 5 years, executed mainly by our BAFA colleagues that you will visit on Thursday. So they have worked with